Welcome. Today we will talk about Nornir. Last week we had Ansible. Any questions so far about Ansible? How is the lab going? Good. Great. So, I believe you realized I'm not the biggest Ansible fan. So I myself like Nornir much more. But in the end, we have to see which tool is the right tool for the job. So, for example, if I would automate a lot of Linux VMs, I would definitely go with Ansible and not with Nornir. If I have to interact with a lot of network devices, if I need some flexibility, I would then prefer Nornir. The goal today, we need to understand Nornir itself with the plugin system it has, and we of course need to understand the Python code. And we also should be able to write some simple Nornir tasks. And in the lab you will have the same exercise as in Ansible, you will also do in Nornir. So there you have to have some more than just hello worlds in Nornir. Yeah. So one of the biggest facts in my opinion, and one of the biggest reasons why I like Nornir, there is no domain specific language. Everything is a Python framework. Of course, Ansible behind the scene is also Python, but here I interact with the Python SDK. We interact with the objects, and Python, some people like Python, some prefer other languages. One of the properties of Python would be that we can do almost everything. Even if there's a person who developed the SDK did not have this intention, we could somehow add this behavior. So Python is extremely forgivable. That's also sometimes something bad, because we have to see about that the code quality still is good. If something runs in Python, does not mean it is Pythonic. It does not mean that it should be like this. So yeah. The other fact is, because it's a Python language, it's a programming language, it's Python, we can almost test everything. If we mock, we can test we can definitely test everything. Without mocking, of course, the interaction with the device is a little more tricky. But it's Python, we can use PyTest, you already know, from the Python module, hopefully. And yeah, so one of the big advantages in my opinion. Last time we draw this beautiful diagram about Ansible. I took the liberty and already did something similar for Nornir. So to save some time, we can read it. It has a lot of, how can I say, it looks similar to the one we draw last week. That's on intention, because it should be easier for us to compare. So Nornir itself, it's a Python package, pip install Nornir. We have Nornir, the core. There was a decision, I think 2 years ago, to exclude almost all the plugins in different Python packages. So if you need a plugin, you would do, for example, pip install Nornir utils, and then you get the plugin Nornir utils. It automatically registers with the Python endpoint magic, and we can use the plugins implemented in this package. But the core itself, we have in the middle definitely the Nornir object. So maybe from the colors, I'm not in a software engineering model, so it's not perfectly UML, so I hope you forgive me. Black normally should be an object, and blue would be functions. Green are plugins. They register with the Python setup magic, and then we can use. So if we start, of course, one of the big thing would be here as well, the inventory. So if we want to automate something, we need to know which hosts do we have, how are they grouped, what properties they have. So we have the inventory. There is actually an Ansible inventory plugin for Nornir, where we can use the Ansible inventory and use it with Nornir. It's not bad. but we don't have all the magic features we have in Ansible. So in Ansible we can do a lot of more stuff in the inventory. There's a lot of we can use Jinja itself in the inventory, for example. All this stuff who are more advanced could be tricky in the Python implementation for Nornir because it's kind of a light version. For most cases it will work, but most of the time we probably somewhen end up and say YAML files with a lot of hosts is maybe not the best idea, so we maybe need to implement our own inventory. So in Nornir it's quite easy to implement your own inventory plugin. You can interact with your systems you have, or there are already some existing plugins for inventories as well, of course. So many examples use the simple inventory. This is a simple implementation who just uses 3 YAML files, host files, group file, and default. In Ansible would be all. Here it's called defaults. So yeah, we have the inventory, of course, and with the inventory we then can run tasks on it. So the idea in the end is to run tasks. So for this, Nornir itself has, of course, the inventory stored in this object. The inventory here with the host, groups, and defaults. We have then a runner. This is normally, or this will be a plugin. There are 2 already in the core. It's the parallel or the serial plugin that we can run tasks. But you would have the freedom to implement your own runner if you need your own logic how to execute tasks. So for example, if you would have a huge company and you want to say, I need my own logic that I can be sure that no one will touch 2 boxes on 2 different sides at the same time, I could implement my own logic to say, to schedule my tasks. So I have never had the need to implement one. It's still on my to-do list because I would fancy to do it, but yeah, so far in production I never needed my own runner plugin so far. Another thing would be processor we have. Oh yeah, also with the processor plugin. So this would be for feedback. If we want to have instant feedback, if we have, how can I say, if we have jobs who run for hours, for example, then we probably need some feedback if still something is running, right? Would be nice to know what is going on. So here, each task who starts, who finishes, who has a result, executes a hook, and with a processor plugin, we then can take this information. We can print it on the normal terminal, but of course we can also put it in a message queue, we can put it in a database, whatever we need. We have the full freedom here as well to implement our own runner plugin. I have done this. Pretty simple, you just need to have the right object, and then you can override the functions you want to implement by yourself. Yeah. In blue, I put it here because it's also important. We have this filter function. So each Nornir object, we can then define the filter and say, for example, I have my whole inventory. I want now to have all the routers with the platform iOS. So I can define the filter, and the return value is a new Nornir object. So I get a new Nornir object, and then I have all the same functionality again. I put here a small f because there is, for advanced filter, this f object where we can have more logic. Here we could do stuff like it needs to be an iOS platform and it needs to be in a group edge router, but it cannot have the username test, for example. Does not make sense, but we could do it. So here, if we need more logic, if we need some Boolean algebra, we can do this in this f object. Or we can also define our own function who returns true or false. The only thing there, if we then talking about thousands of inventory items, we probably need to see about the performance, depending how we implement it. Yeah, but of course we could also filter already before we start Nornir, because it's a Python project. We can also filter in the inventory plugin if we define our own inventory plugin, so all the freedoms. So inventory, I said, there of course we have different inventory plugins, and then there is also this transform function. So if we use, for example, an inventory plugin for our single source of truth, but somehow we need to edit all the hosts, there is already a mechanism implemented that I can write a transform function and pass it there. So that is many cases, for example, used to aggregate the username and password. So there, for example, I could talk to a Vault API and ask for a username, password, or for the certificate or anything, and aggregate it in the memory. Yeah. Connection plugins. There are also a lot of connection plugins we can use. There are, yeah, quite a lot, but still, maybe you need your own. It's not so hard to implement your own connection plugin, just some Python code. And because if we work with Nornir, Python should be familiar to you. It is not such a big deal to implement your own connection plugin, if you would need one. So if you would have, let's say, a special firewall with a special API, and there is no plugin that works for your case, just build it by yourself, and please test it. The only thing you have to be always aware, in the end you have to maintain your solution. So if you write something, please write it nice and maintainable, write tests, because if you need to change something in your connection plugin 2 years after, you will be happy that you have all the test coverage. Python packages, as mentioned, we can just install with pip, and then we will get Python packages. They have one or multiple plugin packages, but they could also just have function and tasks. So we import, we use the function to, to execute the function. If we, for example, want to render ginger template, but this is such a simple function with 3 lines of code, we can also do it by ourselves. But if we would have something more complicated, we could put this in a Python package, install it, and use it. And of course, then with version pinning, we can make sure that nothing breaks by any updates. The biggest part, of course, in the end, is how we use it, right? We have here probably a Python project where we put our automation, where we put our business logic. So we could also do this just in a script, but somewhere we will end up to have more than just 10 lines. So we probably want to start in the beginning with a nice Python package, but it does not have to. Python can be one file if you want. You can create your CLI plugin. You can also create your web server with Flask or Fast API and use Nornir. The only thing, if you, of course, are doing an API and you call a task who is running for hours, then should not be a synchron GET request. Otherwise, the browser will not be happy that the GET takes so long. But this is all just simple Python. So if you are well enough in Python, this should all be easy and logic. Any questions so far? Is it similar to Ansible or completely different? Did I forget something? I forgot the init Nornir. This is just a function to bootstrap to get our Nornir object, and we pass a configuration. This can be a dictionary, this can be a YAML file to say which plugins we want to use and which logging settings, for example, we need to have. No questions so far? Yes. So the question is, why did I choose these different protocols? The reason is, depending what your vendor provides you, you can use different approaches. For example, if an API provides you only, a firewall provides you an API, or SSH probably would prefer the API because it's much easier to integrate than a CLI over SSH. If it's netconf over SSH with RPCs, then it would also be okay to work. But yeah, I choose just different protocols we normally see. But there is no reason why. In the end, you have to see which equipment you have to deal with and what is the best way to interact with them. Yeah. Links. There is Nornir.tech. With Nornir, there is also a collection with all the plugins. Maybe not all, but everyone who created the plugin and registered it there with a pull request, we will find it there. So that would be the first place for me to look if I need a plugin for something. We have, of course, the code itself. Sometimes if you are trouble to understand something, the documentation is good, in my opinion, but the code is better. So many times if I'm troubleshooting something, I will end up in the code. It's easy for me to say because I know the code quite well, not completely without looking, but I know quite some lines there because I'm used to look at this code. But it is Python code. It is not so difficult. Does not have extremely a lot of magic. It has some magic, of course. But yeah, that is also a point to start when you are troubleshooting some issues. Read the docs would be the official documentation. There are some tutorials, some how to install. That would be a good place to start as well. Yes. So the question was, how do I figure out what to pass to a function in Python because Python is not typed? That's a good question. There's a nice answer. So like in a cooking show, I prepared something. No. In Python you can do typing if you want. And the Nornir project, luckily, it does. So here, if you go into the project, for example, let's just go to the core, and then we go, for example, to the inventory. No, that's not so interesting. Let's go to the Nornir object itself. This is the Nornir object. So simple Python object. Let me do it. We have the initialize. So here we see what do I have to pass. So for example, the Nornir itself needs to have an inventory object. This will be done in the init Nornir helper function, so we don't have to initialize the right plugin depending on the configuration. We also will have the configuration. We have here data. Maybe it can be confusing, but here we have a global state. This part is missing in the diagram. Here we basically just have storage for if it's a dry run or not, and we remember all the failed hosts. So by default, Nornir, if a host fails, the next task will not execute on this. We can override this behavior, but the default would be if something fails, we will not continue trying the next task on this host, right? We also have a context manager here. So with enter and exit, you can use in Python this with statement, with my amazing Nornir object as nr, and then we can use nr, and in the end, when we are finished, it will magically close all the connections. We have with processors. So this is sometimes something you need to look in the documentation or in the code. We will see we pass here a list of processors. We cannot just have one processor. We could also have multiple processors, for example, one for storing all the actions or the log more or less in a database, the other one maybe for the user to see, and the third one we could also have a taskbar to see the progress, a progress bar. So we can pass here multiple, so this would be here a list. And because this is typed, we can see it in the code pretty well. If you're used to Python, for me I like this more than any poem to read. It's more understandable. And here we see that the return is a Nornir object as well. So we see also the return value here. Does this answer your question? And in the end you have to... If it's not a types project, maybe there is a docstring, if you're lucky. So it's in a way also typed. Otherwise, you have to see the code. In worst case, you have to put a breakpoint and see what is happening there. Now, depending on how beautiful the code is written, it can be coffee consuming. Yeah. Other questions so far? So this is not a graphic I did. This is from the documentation, just more or less the same we had before, different way to illustrate. So we have inventory plugins. Transform functions is not really a plugin, but it's normally used combined with the inventory plugin. Connection plugins are important. Then we have runners and process at the moment. And because it's open source, if we need anything else, we just create a pull request. So even here, the code is kind of small, let's say. If we compare it to Ansible, this is extremely small, but how can I say? I think lightweight, but better, in my opinion. If I look at this code, I understand it. If you remember the code from Ansible, who was kind of difficult to read, so the code base, in my opinion, the quality is much better in this project. But it's also not so many people working on the same. And yeah. Inventory, as I said, many examples, and also the lab will use the simple inventory. So that is kind of a way that we can easily get started. We have 3 files. We defined in one file all the hosts. So in this example, we would have a switch 1 on port 9. That's the name in the inventory. And then we have host name. We can define the port, platform, and the list of groups. So we can group them. And now the most important part probably here is the data part, where we have a dictionary. We can put anything there. And Nornir itself will then kind of merge the defaults with the groups in the host. So if we define something on the host, it has the highest priority. So we can override something from any group or from the defaults. And so we can then arrange our data. In this data, we can define our own types. If we want to use the site, we define site. If we think we want to work with tags, we work with tags. Yeah, we have all the options here as well. Of course, we have to be aware that this is merged together, and if you have nested stuff, it can be overwritten. Yeah, looks pretty simple. It's YAML. Of course, if we write our own plugin, there are plugins for even for Excel. Please don't use Excel, but yeah, there would be plugins for a lot of stuff. Otherwise, you write your own plugin. I think in an hour you have your own plugin if you want. That is doable, depending what kind of magic you need. In the groups, we can then use, for example, the same hierarchy, and in the data we can define tags. So for example, I would say in this group the tag OSPF. So if I have a task later, I can say run this task on all the machines who are having the tag OSPF. So in the filter option we saw, we can not only filter on the properties like username platform, we can filter deep into this data structure we defined. So we can define our own data structure, we can use this in the filter, so there's a lot of power if we know what we are doing. And then here would be the configuration. The default is not used here, but we would also have option to have the inventory option default file. So we have all 3 levels. These options are just passed to this object simple inventory, and this simple inventory now is from Nornir, but we could also use our own. So depending which plugin we use, we have different options. If we use a plugin for a single source of truth, we probably have to provide the API URL and some credentials, hopefully. So yeah, we have different possibilities here. And as an example, we have here the threaded or parallel runner. We defined we have 100 workers, depending of course what kind of machine we have, what kind of task we are running. We can yeah, scale this up, but also for any task in our, let's say, Python object, in our Python project, we could define for one task another runner, and then do something serial, for example, and then we could run parallel again. So a lot of flexibilities. We can have a lot of fun. I try to paint it a little, but in the end we have objects for hosts. So all the hosts is just a Python object. We have all optional host name, port, username, password, platform. If you look at the code, funny, the group is actually, I can show it, I think I have still it open. The group is actually just the same like a host. If everything makes sense, if it makes sense to define the host name on the group, probably not. I could, but yeah, does not make sense. So in the end, we also have to know what we are doing. So this is the definition, and the host must be, yeah. And then we have hosts, who is actually a dictionary with strings and hosts, and this is then stored in the inventory. So we can use the inventory like a dictionary to work with the hosts, as an example. So we have the hosts. Each host has this data we saw. Oops. And of course all the groups have it. We have here this parent groups object. This object is only used that we don't have a group multiple times in this list. So to have a unique list, this parent group object is used. Because we can nest groups and all the stuff, we need to be sure that we have each group only once in the list. Then we can define the connection options. So this would be the options we pass to a connection plugin. Let's say I want to define username password for the API, but I need different username passwords for the SSH. I cannot work with this username password here. So in this connection plugin down here, I can define and override all this stuff specifically for one connection plugin. Also this extras here is again a dictionary who will be passed to this like connection plugin. So if I for example want to trigger or control some delays or logging level of this connection plugin, I can use these extras again. And sometimes you have some stuff here you pass to the connection plugin, and the connection plugin will then pass this to the plugin it uses. So yeah, I can get a little, how can I say, this stuff most of the time needs for me to look into the code or documentation until I know what I exactly have to pass to which one. But if it's designed and programmed in a nice way, we can get a long way with that. Yeah, we have a lot of functions. So the host itself, the idea is that it acts like a dictionary. We can use a get to get a key, and it automatically will then look in the host or in the groups or in the default. So here the get is overwritten in the code. If I anyway have it open, why not show it if I find it fast. The get will just return the same with the brackets with the straight ones. So we have to look at this implementation. This implementation here will first look in hostname, port, username, password if something of this is asked, because this is a property of the object, and then it will just use the extended groups, so it will generate all the data from default and groups together, and then it will just do a normal dictionary lookup like in Python. Yeah, so we can work with this similar to a dictionary. That's also handy if we pass, or if we are rendering, for example, Ginger templates, and we pass the host object, we have access to all of these functions. Or we can work with it as it would be a huge dictionary for us. Yeah, because group is actually more or less the host object. It also has all this function here. If it comes to the connections, we could open a connection on a group. I have never done this. It's just, yeah, it would be possible. I don't see a reason why we should open a single connection on a group. So this one will not connect to all the hosts in this group and open the connection. This will just on this object open a connection. So please, before you use them here, write me a message and ask if you're on the wrong track. Because most of the time we want to work with these functions here. The close connections could be something, but no, also not. I never have used these ones in any production code, and I think I have written a lot of Nornir code in my career. Yeah, any questions so far? Simple. So how simple is it? This would be a hello world. We import in the beginning init Nornir, so we need to have this function to bootstrap our Nornir object. We have two imports here, core task, the task and the result, only for typing. So this would be not really needed in this code, but because I'm a fan of typing, we can use here our function hello world. This is now a task function, or we define this can use as a task. The first parameter needs to be task, and it will be from the type task. This is not needed, this double colon task, but it will help you if you use Visual Studio Code or PyCharm or any decent tool to program, that in the end, if we use down here the task object, it will already know that there is a host property, and the host is then the host object who is in the inventory, and here I can then completely access the whole host object. So this helps us also for the code completion, also for finding errors, and in my opinion it makes it much more readable. I know that here, for example, I will return a result object, and here best practice is to always return a result object, and as a host I define the host again, and as a result here I would have this string message. So if I now have 10,000 host objects in my inventory, I could run this task on all of them, depending on how many runners, workers I have at the same time. But because this code is not really doing anything, it will be pretty fast as Python at the moment is. But I think if we are doing network automation with devices, the Python speed will not be our first issue. Question? Which one should be a reference? Yes. The return result returns a Python object who is in the end somewhere in the memory. So we have a pointer to this Python object who is returned, yeah. So the return value, yeah, it has to be in a shared space, like Python, yeah, it's in Python. Luckily, we don't have to really care about heap and stack and all this stuff. If we want to care about this, we will go to the fun languages. But Python, in the end, Python is. Some people say Python is like YAML for data modeling. We write Python. In the end, it will be C code. But who wants to write C code? To be honest, right? I know some people, but definitely not me. So yeah, this will be in the memory, of course, an object with a pointer, and will return. Funny part here is that here this run result, it will not return as a result object. It will return as a aggregated result object, because there in the background needs to be some magic, because we have one task, and this one task returns one object as a result, right? And then we run this on multiple hosts. So here we need to have a mapping for which result belongs to which host. And then we also can nest or have multiple tasks. So for each host we can have more than one task, because in this task here we can do again task.run and run another task, and then we can define multiple tasks we wanted to execute. So we also need some magic there to resolve this. This can be in the beginning a little overwhelming to see how this result ends up in this aggregated result. Yeah, so I also made a drawing for this morning. Hope it is correct. What we also see here is this Nornir rich. So this one here is actually not from Nornir. This is another Python package. So this is a Python package who gives us a function called print result. This one prints it with the Python library rich, little nice, colorful. I like this library, but there is officially the more light version with the Nornir utils, where there in ASCII is the result printed. There is the same print result. This is just a helper function that we can see the result. But also we could, here in this Nornir rich, for example, there is also a processor to have a progress bar. All some fun stuff. Yeah. Okay, so let's focusing shortly on these results we get here, because most of the time we want to do something with an execution, or we want to print it. So as I said, we have this aggregated result. So this is actually an extended dictionary where we have the key, the host who was executed on, and then the multi-result. So each key has a multi-result, and the multi-result has a list. This is also an extended list object with a result object in. The result object is the one we returned in this task function. And the aggregated result is the one we end up in the end of the code when we store this in the in this result variable results. So here we have the the aggregated result, and we return the result object. So if we run multiple tasks, for example, there is no need to aggregate them by ourselves and return. Nornir itself will aggregate all the tasks into this multi-result object. So what actually is happening, we have the Nornir runner who will execute our tasks. So it will define how many can I make parallel, do I have to make it serial, which one can I, let's call them schedule or execute, run, and it creates a task object that's internally. Normally we don't see the task object a lot, but this is the task object who is given to the task function, so we can use this task function to run new tasks again. So there we have this shared multi-result. So this task for each host would be then given to all the task functions. So that is the reason why we then have the same multi-result and aggregate here. We have start. So if from the runner we run a task, it is started. And if it's ended, we will store the result in this aggregated list. So the first task we execute is always the last one in this multi-result list, because if we in the task then execute a new task with run task.run, it passes the same object, it will start again a job. When it's finished, it will be added to this list. So one thing that can be confusing, that the first task is the last one in this result here. But it's just how it is designed. Yeah. We have of course also some properties here, like we can see if any task has the property changed, if any task is failed. We can also raise exceptions if we want to use exception handling for our flow control, for example. The same or similar ones we have on the aggregated result, because many times first thing we want to know is everything okay, or do I have a failed task? If I have failed task on the aggregated level, I want to know which host was it. So there is a failed host function we can call. On the multi-result, there is no other host, so this is for each host. And here of course we don't need these properties because we have direct access. We have a result who is actually anything if we look at the typing. Here I have to see what does the task I'm running actually store there. So because this is so open, it can be anything, it can be an object, it can be a string, it can be an integer, all the possibilities. We have changed, we have diff, who is normally a string, because in the beginning it was when the whole thing started, a lot of CLI interaction were done, like we did with Ansible. So this is kind of from there that this is still a string. We have exceptions, so if somewhere an exception is raised, we store them in this object, result object. We have severity level. So here we can, for example, define that some results are more important than the other ones. So that is handy if we want to have a lot of tasks, but maybe we only want to show to the user the ones with the good severity level and with info. But if we have a severity level of debug, we want, if we use print result, we don't want to show them, because otherwise, if we have many tasks, many hosts, this can be a lot of information. So this can be used for filtering, and yeah, in the end, everything is Python, so we can do almost everything you can imagine. Any questions? Everyone happy? At the beginning, maybe you will think, yeah, Ansible is not so bad. If you do a lot of network automation, you will appreciate the flexibility of Nornir, because in many cases you need to do workarounds and some stuff you would not be used for. Let's say if you are back and front end developer, everything works perfectly, but if you interact with network devices, you will many times have a lot of coffee consumed. Let's say coffee. Okay, thank you very much. If you have any questions, just drop me a message.